Hi, Eric the ITGS Guru here, and today we're going to be talking about other artificial intelligence techniques, such as searching. A common artificial intelligence technique is searching. Searching considers most, if not all, possible solutions to a problem in order to find the most appropriate one. It is often used by software that plays games, like checkers or chess. And here you can see a chess game that's using searching in order to determine what moves it's playing, and you can see it says Alan Turing versus whoever that is, and Alan Turing is the person who created the Turing test, which is supposed to be able to tell if a computer is intelligent or not by being able to pass itself as a human. How searching works in chess. For example, playing as white in a game of chess, a searching algorithm would consider all possible white moves that could be made, usually about 30. Then every possible black move that could be made for each of those white moves, which is 30 squared. Then every possible white move for those black moves, which is 30 cubed, and so on. The software will get increasingly complicated, and right here we have an example of searching used in tic-tac-toe. And the reason I use tic-tac-toe instead of chess is because chess gets really complicated and it's really hard to demonstrate how it's working and how it's doing what it's doing. And tic-tac-toe's same principle, it's just a lot simpler. So here's a little illustration of how searching is used when a computer is playing tic-tac-toe. Depth of the search. The depth of the search, or the number of moves ahead of the computer examines, depends on the software and the available computing power. Searching requires powerful computers because the number of possible outputs becomes very large very quickly. The Deep Blue chess computer employed searching to beat world champion Garry Kasparov, looking an average of 8 moves ahead, but able to search up to 20 moves ahead in some situations. Brute force, obviously brute force computing, is searching and sometimes called a brute force approach because it uses sheer computing power to achieve its goals. Which means there's a lot of processing capability, a lot of computer there. Brute force. The idea is to try thousands of different conditions like temperature, humidity, tensile strength, or shape in just a few seconds. Most of the outcomes will be lousy. A couple of them will probably affirm what a designer thought to begin with, and a few might deliver surprising insight no one had considered. The hope, Mr. Bass said, is that we give an engineer a greater capability to understand their product before they make a million of them. And a good example of this is I was reading a magazine the other day, and they were talking about the new Corvette used about, I think, 10 million computing hours in order to determine the aerodynamics of it. And I was thinking, well, how the heck could they do 10 million hours if, obviously it didn't take that long to engineer? And brute force computing would be the main thing that enabled that to happen. Google's successful language translation. Brute force computing is also behind Google's successful language translation. By comparing thousands of web pages in different languages to find patterns, in 1 year Google was able to discern and refine translation better than linguistics theorists have been able to do with their fancy programs for years. There's brute force in this approach too. Machines plow through massive amounts of different information in order to find and examine the different components that are necessary to them. Here you can see a picture of Google's language tools and some different options that it allows. Brute force hacking. Brute force is about overpowering the computer's defenses by using repetition. In the case of password hacking, dictionary attacks involve dictionary software that recombines English dictionary words with thousands of varying combinations. Yes, much like a Hollywood safecracker movie scene, but much slower and much less glamorous. Brute force dictionaries always plus start with simple letters, A, and then eventually move to full words like dog, doggy, doggy, spelled different ways. These brute force dictionaries can make up to 50 attempts per minute. And here you can see in this picture, it is a command prompt of a password cracker, and you can see some of the different commands that go into that. And here's a bibliography of some useful sources that went into creating this video. And here at ITGS Guru, we close with, stay nerdy, my friends.